Let's look at a second example. Okay, let's look at another example. A question. Let's look at the example. A question is asked in the sample survey. Do you like scarce teaching style? Okay.
Yeah.
Now, this is a count box or this is a sum box? People say yes. Count is 1 yes. People say no. Huh? Count is 0. Right? 1 yes. Huh? No for what? 0. Okay? So you are counting how many people say yes. So this is a count box. Okay? This is a count box. This question is asked in the sample survey. And what we want to estimate, we want to estimate the proportion of getting what? Number 1 ticket in the box, in the population. So this pi is a population percentage of what? Student who like scarce teaching style. So we want to estimate what? Population percentage. Okay? So as I mentioned before, this is without replacement. So you're going to see finite population correction factor. Okay? Now, if this is the case, which class predicts better? I give you 2 classes. Class 1, class 2, okay? Now, class 1, what's the class size? I have 400 students in class 1. And how many people in class 2? Huh? Only 40. So this class is 10 times more students in this class. Now, most people, if they never learn statistics, they say, okay, from the bigger class, I take 20, randomly select what? 20 people. My simple random sample size is 20. 20 over 400. The sample size over population size, 20 over 400. The ratio is what? 5%. In order to get the same accuracy in the smaller class, the class has 40 students, I should also take 5%. And 40 times 5% is 2. That is to say, if a student or a person never learns statistics, he would imagine from the last class, I use what? 400, a large class of 400 students. If I use 20 as a sample size, which is 5%, right, of the population. In the smaller class, I should also use 5% to get the same accuracy in prediction. But this is wrong, okay? After you take this course, you should know, okay? If I ask you to choose A, B, C, which class predicts better? Class 1, class 2, or equally well for the prediction? Okay? Most people, if they see this is 5%, this is 5%, they will choose C. Equally what? Accurate. But that's wrong. Okay? Let's see why this is wrong. Note, little n over capital N is 5%. What does that mean? That means this ratio is what? That means this ratio is 1 over 20. And that is precisely population size is 20 times bigger than sample size. When population size is 20 times bigger than the sample size, the finite population correction factor will be what? Will be close to 1. That is to say, SEX bar, or earlier I say W, right? W. W is what? SEX bar will be sigma over square root n times square root of capital N minus little n over capital N minus 1. Okay? But this is almost 1. So SEX bar, or accuracy of the prediction W, depends only on what? Sigma over square root n. Is the one with bigger sample size will predict better. Am I correct? It's nothing to do with what? 5%. How population size, relative to what? Sample size. Nothing to do with this 5%. Is that clear? When population size is 5% or even smaller, right? How population size relative to the sample size doesn't matter. Because finite population correction factor will be very close to 1, right? What determines the accuracy? The one with bigger sample size will what? Predicts better. This one, sample size is 20, this one is only 2. So which one predicts better? Class 1 or class 2? Class 1, okay? Because class 1, the sample size of class 1 is what? 20, which is much, much bigger than what? 2, which is the sample size of what? Class 2. Okay? So class 1 predicts what? Predicts that. Okay? Choose what? Choose 8. Okay? Choose 8. Is that clear?